In this video, we're going to discuss how to interpret the slope in an application problem. So we've talked about the slope in a variety of ways. We've talked about it as rise over run when we're graphing, or change in y over change in x. When x and y are representing quantities in an application problem, then that slope is representing the rate of change of something. So we're going to look at a couple examples here. So suppose we have a parking garage that charges $2 as soon as you enter, and then they also charge $3 for each hour that you park there. So we're going to write an equation to model the cost y to park for x hours. So the cost is going to be $2 plus whatever you are charged for the number of hours you parked. So if you parked there for x hours, it's $3 per hour. Then the equation for the cost would be y equals 2 plus 3x. Now this almost looks like slope-intercept form, right? If we switch the order of the terms. Now it looks like y equals mx plus b. And so the slope is m, the number in front of x. So the slope here is 3. So what does that represent? It represents the rate at which the cost is increasing, right? It's increasing because it's a positive slope. The cost y increases as x increases. X is the number of hours. So this is just representing the hourly cost for that portion of the cost. So you could think of it as the amount the cost increases per hour. Here we have another example. A printing press is purchased for $90,000. The value of the printing press depreciates, so it's decreasing. This happens with a lot of expensive items, computers, cars. So it's depreciating by $6,000 per year. So we want to write an equation for the value y of the printing press x years after it was purchased. So the value is going to start at $90,000. So when x is 0, right, 0 years after it was purchased, the value is 90,000. And then 1 year later, it's going to decrease by 6,000. And then 2 years later, it'll have decreased by another 6,000. So basically, it's starting at 90,000, and then the value is going to decrease by 6,000 per year. And again, this is almost slope-intercept form, it's just the terms are reversed. So when you're rewriting it, you want to make sure and keep the signs the same. So the x term is negative, so that should still be the case when we write them in a different order. And the 90,000 was positive. So now this is that y equals mx plus b form. So m is the slope. The slope is negative 6,000 here. The slope is negative, which means something is decreasing. The value of the printing press is decreasing, which we knew from the problem. And the problem even tells us it's decreasing by 6,000 per year. So that's what the slope represents in this case. It's the amount that the value decreases per year.